Tesla bought Gen 3 stuns with a custom-built actuator weighing just 5 pounds, yet capable of delivering 110 pound-feet of torque. Each joint can lift over 45 pounds while consuming only 100 watts of power, setting a new benchmark for energy efficiency in robotics. Tesla only expressed confidence in calling it the most efficient actuator they've ever built. How might this exceptional efficiency reshape the future of humanoid robotics? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla bot, Tesla EVs, and the latest news. How is Optimus designed to be both powerful and energy efficient? When Elon Musk claimed,
I think humanoid robots will be the biggest product ever. The demand will be insatiable.
You've said that.
Everyone's going to want one. It's like, basically, who wouldn't want...
how could a humanoid robot be strong enough to lift heavy loads, light enough to move gracefully, and energy efficient enough to operate for hours without recharging? The answer lies in the heart of the machine, its motor system. And unlike most robots on the market, Optimus doesn't rely on off-the-shelf motors. Tesla has redesigned everything from the ground up. Each motor on the Tesla bot is custom-built for its specific location on the body: hip joints, knees, ankles, shoulders, elbows, wrists, even fingers. There's no one-motor-fits-all approach. The leg joints need to handle large amounts of force to lift the robot's entire body when standing or walking. So Tesla developed high-torque motors specifically for those points. Meanwhile, the arms and wrists require agility and fine control for precise gripping, so those motors are tuned for speed and accuracy rather than raw strength. This task-specific design allows Tesla to optimize every pound of weight and every watt of energy the robot uses. Imagine the robot working in a kitchen. When it bends down to pick up a 20-pound bag of potatoes from under the table, the motors in the hips and knees must coordinate to produce smooth, balanced force. These leg motors must be strong enough to lift both the robot and the bag. Immediately after, as it raises the bag onto the countertop, the arm and wrist joints must shift to a lighter, controlled movement to avoid knocking over objects nearby. This ability to shift fluidly between brute strength and delicate precision is rare among today's robots, and it's only possible because of Tesla's smart motor design. Or take another example. Inside a warehouse, Optimus is asked to lift boxes and place them on high shelves. As the arms rise above the shoulders, the robot needs to maintain balance, requiring the legs and hips to compensate. At the same time, the motors in the shoulders and arms must be strong enough to lift the load, but precise enough to place it exactly. This requires fast-responding actuators with dynamic torque control, something Tesla achieves through direct drive motor systems that don't rely on gearboxes or complex mechanical linkages. The result is not only greater efficiency, but significantly faster reaction times when the AI gives movement commands. What makes Tesla's design so exceptional is the power-to-weight ratio of its actuators, which exceeds that of most other humanoid robots. The Gen 3 Tesla bot weighs less than 132 pounds, but can lift objects weighing nearly 45 pounds with both arms. An impressive mechanical feat, especially considering all of its motors are compact and fully integrated without the need for external gears or assistive supports. While industrial robots often rely on large gear systems or bolted-down mounts to achieve similar strength, Optimus achieves it with compact, energy-efficient direct-drive motors. Another major differentiator lies in Tesla's optimization of electromechanical efficiency within each actuator. They've gone beyond just reshaping the outer casing. They've re-engineered the internal coil windings, permanent magnets, current control systems, and embedded the motor controller directly into the actuator module. Unlike conventional motors, which suffer from heat loss and inefficiency during energy conversion, Tesla's system maintains precise, real-time adjustments to frequency, voltage, and current direction in order to generate smooth torque with minimal waste. This reduces heat buildup, conserves energy, and significantly extends motor life. What's even more impressive is that most of Optimus's joints don't need active cooling. There are no fans, coolant pipes, or pump. Cooling is achieved passively through smart component layout and heat-dissipating materials. That's a huge advantage over many existing robots, which often have to compromise on weight or generate significant noise to keep motors from overheating. Tesla's approach makes the robot quieter, more energy efficient, and easier to maintain, especially valuable in home, hospital, or office environments where both noise and power usage matter. Even more crucial is Tesla's design philosophy. Don't overbuild the motors and then throttle them with software. Start by understanding what the robot needs to do, then build motors that are just powerful enough for those real-world tasks. Most home and factory jobs involve slow, repetitive movements that don't demand maximum output. Walking, lifting boxes, wiping surfaces, opening doors, sorting objects. Tesla has accounted for all of this by designing actuators that perform these motions smoothly and consistently, without excess power consumption. This allows the robot to use smaller battery packs, reduce overall weight, and extend usable runtime. It's also the key to hitting a consumer-level price point under $20,000, a figure Elon Musk has openly hinted at, something that could bring about a robotics revolution as significant as the smartphone era. In short, the motor system is the key enabler that turns Optimus from a technology demo into a truly functional product. Strength alone isn't enough. Tesla has proven that with a ground-up design, component-level optimization, energy-saving focus, and scalable production methods, a humanoid robot can be intelligent, powerful, and practical for everyday use. In the world of robotics, where every pound and every minute of battery life counts, what Tesla has achieved with the Gen 3 Optimus motor system isn't just engineering progress. It's the foundation for a product ready to enter the real world and the global market. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. How does Optimus control its movements so precisely and intelligently? When people see the Tesla bot performing actions like walking, turning, or precisely reaching out to grab a small object on a table, what they're really witnessing isn't just mechanical movement. It's the result of a highly sophisticated control system working silently beneath the surface, a kind of digital nervous system developed by Tesla to unify every actuator and sensor into one cohesive command network. While the mechanical design is impressive, Tesla's real advantage lies in how it optimizes actuation through control technology that few robotics companies today can match. Unlike traditional humanoid robots that separate hardware, motors, sensors, from control software, controllers, Tesla takes a biologically inspired approach, integrating low-level and high-level control into a unified central nervous system. This means that instead of components operating independently and then reporting back, Tesla has built a hierarchical control architecture that processes sensor data and motion commands in real time at the module level, then synchronizes it across the entire robot using a neural network trained by Tesla itself. During a live stream in early 2024, Elon Musk emphasized the brain and the nervous system of Optimus are essentially extensions of what we built for self-driving. It's all real-world AI. Thanks to its foundation in the same AI platform as Tesla's autopilot, the robot doesn't just respond to environmental inputs, it learns how to optimize behavior over time, like a living organism gaining experience. One of the key differences lies in how Tesla applies bio-inspired control algorithms. Rather than relying solely on traditional dynamics equations, Tesla trains deep learning models to handle unpredictable scenarios, such as slips, resistance, or unintentional collisions. This allows Optimus to react flexibly in the real world, where conditions are rarely ideal or consistent. For example, when the robot steps onto a sidewalk that's slightly higher or slicker than expected, foot sensors detect the abnormal slope. The signal is processed locally in the limbs control module, and within milliseconds, torque adjustments in the knee and hip are made to maintain balance. Crucially, this process doesn't need to pass through a central processor and wait for feedback. The distributed control system is intelligent enough to act immediately. This is why Optimus can walk smoothly like a human, rather than in stiff, jerky motions like many robots. Tesla's control system is not just flexible, it's highly energy efficient. Whenever the robot performs a task like reaching for a bottle of water on a kitchen shelf, Tesla's motion planning algorithms calculate the most optimal path, the shortest distance, the fewest joints to move, and the least energy required. As Musk stated during AI Day, it has to be extremely efficient. This is not just about making a robot move, it's about making it useful. And indeed, Optimus doesn't just move, it moves with purpose and maximum conservation. Tesla has also integrated reflexive learning through billions of data points gathered from autonomous driving and factory simulations. Unlike other robotics companies that train every action manually, Tesla has built a smart control network that transfers knowledge across domains. The way a robot balances on a slippery floor may be informed by how an FSD-equipped Tesla handles a wet road. The subtle adjustments it makes to pick up a glass of water might draw from data gathered on the Model Y assembly line. What further sets Tesla apart is that it doesn't treat control systems as separate from hardware. Tesla develops its own control chips, PCBs, firmware, and operating software, so that everything works seamlessly as a unified whole. Its real-time control system processes signals at extremely high speeds, often between 2 and 5 milliseconds, allowing the robot to respond nearly instantaneously. This level of responsiveness is rare in humanoid robotics, where many systems suffer from tens of milliseconds of latency due to fragmented architecture. This precision is essential in tasks requiring rapid reflexes. Picture Optimus working in a crowded restaurant, carrying a tray of drinks. If someone accidentally bumps its shoulder, the robot has less than half a second to rebalance and avoid spilling the tray. Waiting for central AI commands would be too slow. But thanks to Tesla's smart distributed control, torque adjustments are made simultaneously across joints, allowing the robot to react instantly and retain balance. Tesla is also applying reinforcement learning, so the robot can refine its behavior with every attempt. For instance, when Optimus learns to open a refrigerator for the first time, it tries different methods and forces. After several attempts, the control system figures out the most effective strategy without human coding. This real-world adaptability means each repeated action becomes more accurate and more energy efficient than the last, and Musk's ambition doesn't stop there. In a March 2025 livestream, he revealed, "You'll be able to give it a vague command like clean up the living room, and it will figure out the rest on its own." It's a shift from step-by-step command execution to goal-level autonomy, a massive leap for robots living among humans. Ultimately, Tesla's control system isn't just the robot's brain, it's the system that binds all its senses, muscles, and actions into a unified ecosystem. No amount of sophisticated hardware can reach its full potential without intelligent control, and it's here that Tesla truly differentiates itself, not just creating a machine that moves, but one that adapts, reacts, and completes tasks like a true partner in the human world.
So it can be a teacher, babysit your kids, it can walk your dog, mow your lawn, get the groceries, just be your friend, serve drinks, whatever you can think of, it will do.
That's how Elon Musk envisions Tesla Bot, a truly all-purpose companion. When people hear the term AI housekeeper, the common reaction is, it must be extremely expensive. But with Optimus Gen 3, Tesla is aiming to change that perception. So, is owning such a robot truly expensive or surprisingly affordable? Before we begin, please help us reach 12,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla Bot, Tesla EVs, and the latest news. What is the real cost of owning an AI housekeeper like Tesla Optimus? Currently, Elon Musk has shared that Tesla expects the price of an Optimus robot in the future to be lower than that of a typical car, around $20,000 or less. This price, equivalent to approximately the cost of hiring a full-time housekeeper or caregiver for 3 to 5 years in many developed countries. For context, a full-time domestic worker in the US or Japan may earn $30,000 to $45,000 per year, not including welfare benefits, insurance, paid leave, and other social expenses. In the long term, a robot capable of working 24/7 without holidays, sick days, or turnover could be a cost-saving investment. However, the total cost isn't just about the purchase price. One major question is, how much will it cost to operate and maintain Optimus? Here, Tesla holds a key advantage over traditional robotics companies. Its entire operating system, processor chips, and control software are developed in-house. This helps reduce licensing fees, reliance on third-party components, and update costs. Moreover, Elon Musk has suggested that Tesla may offer leasing or monthly installment plans for Optimus similar to Tesla's full self-driving (FSD) subscription, which currently ranges from $99 to $199 per month. If a monthly rental plan is applied, say around $500 a month, households could access a domestic robot at a much lower cost than hiring a human worker. Beyond that, Tesla may also implement a robot-as-a-service model, where users don't need to fully own Optimus, but instead pay based on usage, by the hour, by task, or on demand. This model is especially suitable for small households, elderly individuals living alone, or families needing occasional assistance. With global connectivity and over-the-air software updates, Tesla can remotely monitor, update, and service the robot, greatly reducing maintenance costs. From an initial investment perspective, some might argue that $20,000 is still expensive, but it's important to take a broader view. Optimus is not just a mobile vacuum. It's a 173 centimeters tall, 56 kilograms humanoid robot capable of walking, grasping objects, communicating in natural language, and learning new skills via video. It can perform a wide range of tasks simultaneously, something that specialized appliances cannot. For instance, a high-end robot vacuum like the Roomba i7 Plus costs about $1,000 and performs only one task. Dishwashing robots, robotic mops, or elderly care devices all come with separate costs. Optimus could potentially replace many of these devices in a single product. From a socio-economic perspective, if Tesla can lower the price of the robot to below $10,000 in the future, Optimus could spark a revolution in the home service industry. In many developed countries, aging populations are placing enormous pressure on care systems. Nations like Japan, South Korea, Germany, and Italy are all facing severe shortages of caregivers. A robot that can assist with mobility, medication reminders, meal preparation, and emergency alerts would significantly reduce care costs and improve quality of life. In developing countries like Asia, domestic robots are still considered a luxury. However, if Tesla applies a global manufacturing strategy, robot prices could drop rapidly, just like smartphones once did. Within the next 5 to 7 years, a standard Optimus could be priced at just $8,000 to $12,000, comparable to a premium electric scooter. At that point, middle-income families may begin to seriously consider investing, especially if the robot can replace multiple recurring living expenses. Moreover, the hidden cost of lacking household support is significant. For busy individuals, spending 2 to 3 hours a day cooking, cleaning, washing dishes, or caring for elderly parents amounts to 15 to 20 hours per week, or nearly 1,000 hours per year. When converted into opportunity cost, such as time for work, rest, or self-improvement, having a robot helper could bring economic value far exceeding the initial purchase. If viewed in isolation, $20,000 may seem expensive compared to traditional home appliances, but taking everything into account, the robot's 10 to 15-year lifespan, its ability to replace multiple tasks, low operating costs, and the value of saved time and effort, then an AI domestic assistant like Tesla Optimus is in fact a very cheap investment in the long run. Elon Musk isn't just selling a robot, he's offering a piece of the future where people are freed from repetitive chores to spend more time on what truly matters. Once again, please help us reach 12,000 subscribers. This is important for us to stay motivated. Thank you. Which features make Optimus suitable as a household assistant? Tesla Optimus is well suited for domestic work because it possesses all the key qualities required: agile movement in home environments, dexterous human-like hands, natural language understanding, and the ability to learn new tasks. These are areas where current household robots still fall short. First, Optimus can move like a human. With a height of 173 centimeters, a compact build, and excellent balance, it can easily walk through their rooms, climb stairs, step over carpets, or avoid floor obstacles. This gives it a major advantage over wheeled robots, which are restricted to flat surfaces. Another standout feature is its 11-degree of freedom hands, allowing it to naturally grasp various objects like spoons, cups, knives, water bottles, and towels. Tesla designed its finger joints to mimic human hand anatomy and equipped the fingertips with force sensors that precisely control grip strength, preventing slips or breakage. This enables the robot to perform tasks such as dishwashing, folding laundry, retrieving items from the fridge, or attaching mop heads, chores that demand fine motor skills. Optimus doesn't just act, it understands. Users can say, "Prepare a simple dinner," or "Clean the living room," without using an app or command code. Tesla has integrated a large language model to help the robot interpret context, extract key instructions, plan actions, and respond accordingly. This is especially valuable for elderly people or children who may not be familiar with technology. Beyond language, Optimus can learn new tasks from video. Users only need to record themselves performing an action, cooking a dish, folding a towel, or watering plants, and the robot can analyze the steps, memorize the process, and replicate it. This personalized learning capability allows Optimus to adapt to the specific routines of each household, rather than functioning with pre-programmed behaviors. In addition, Optimus is equipped with a powerful vision system capable of recognizing objects, determining their location, and avoiding collisions. Its visual processing chip, similar to the one in Tesla's self-driving cars, enables real-time perception. For example, if it detects spilled water, it can alert the user or clean it up before someone slips. It can also read labels, check expiration dates, and assist in food preparation and smart storage. Equally important is its safety in operation. Tesla fitted Optimus with full-body force and collision sensors, allowing it to stop immediately if unexpected contact occurs. If a child runs by while the robot is carrying water, it will halt to avoid spilling or causing accidents. This makes it reliable for continuous use in a family setting without posing risks. Its ability to operate independently 24/7 is another major advantage. Optimus can schedule its own tasks throughout the day, mopping in the morning, cooking at noon, folding clothes at night, all based on the household's daily routine. Over time, it learns and optimizes its performance, reducing the need for repeated instructions. Once programmed, it can carry out tasks automatically on a daily basis. Finally, Optimus supports over-the-air software updates. Tesla uses this system to remotely upgrade the robot's AI, add new features, or fix bugs, no technician visit required. This ensures that Optimus continues to improve over time, unlike traditional household devices that grow outdated. Elon Musk once said, "Optimus will be able to do anything that humans don't want to do." And in the home, that includes cleaning, washing dishes, cooking, doing laundry, and caring for the elderly. With a human-like frame, dexterous hands, intelligent vision, task learning ability, voice comprehension, safe interaction, and continuous self-improvement. Optimus stands out as one of the few robots truly qualified to become a full-fledged AI domestic assistant. Tesla isn't just building a support device, they're creating a day-to-day companion for human life. How does Tesla ensure that Optimus doesn't cause accidents in the kitchen? The kitchen is one of the most hazardous areas in a home. Sharp knives, boiling water, hot oil, slippery floors, electrical appliances, and the unexpected presence of children or pets all contribute to a high level of risk. For a humanoid robot like Tesla Optimus to operate in such an environment without causing accidents, Tesla has developed a multi-layered safety system encompassing hardware, software, and intelligent reflex mechanisms. The first crucial element is a full-body collision sensor system. Tesla equips Optimus with force sensors in areas like the shoulders, elbows, wrists, knees, and back, enabling the robot to instantly detect physical contact with objects or humans. If any abnormal force is detected, say a person reaching in while the robot is working, the system immediately commands the robot to stop all movement. This safety mechanism is similar to Tesla's emergency braking system in its cars, designed to prevent accidents in a split second. Next is the motion constraint layer, a behavioral control algorithm that limits the robot's speed, force, and movement paths, depending on its environment and the tools it's handling. When Optimus is holding sharp objects like knives or hot items like soup pots, the software automatically slows its arm movements and restricts its motion trajectory. This ensures that even in the case of a software glitch, The robot cannot swing its arm erratically or dangerously like traditional machinery might. Tesla also equips Optimus with a computer vision system tailored for home environments. The robot can detect warning signals like the red glow of an active stove, faint smoke from burnt food, the sheen of oil on the floor, or even identify faulty power outlets through its multispectral cameras. These signals are processed in real time, enabling the robot to halt, avoid hazards, or alert the user as needed. Another critical safety layer is real-time reflex AI. Tesla has trained this system using millions of simulated emergency scenarios, such as a child running past while the robot is carrying water, a pet darting underfoot, or objects suddenly falling from cabinets. In such cases, the AI reacts instantly, stopping the robot's motion, retracting its arms, or adjusting its posture to prevent a collision. Elon Musk once declared, "Optimus must be safe even if you try to attack it." This means the robot must not only operate safely under normal conditions, but also be resilient enough to remain harmless even during unexpected interactions, like a child climbing on it, an elderly person grabbing it for balance while it's moving, or someone deliberately pulling or pushing it to test its limits. As a strategic move, Tesla is first testing Optimus in its own factories, complex environments that are still carefully controlled. Engineers there deliberately create risky scenarios such as spilled oil, high heat, dangerous tools, or narrow pathways to evaluate how the robot responds in practice. Only after thousands of hours of successful trials in industrial settings will Optimus be deemed safe enough for home use. Additionally, Tesla leverages its over-the-air OTA software update system, allowing Optimus to continuously improve its ability to handle dangerous situations without needing hardware changes. For instance, if a robot fails to detect smoke from a burning pot in one home, that incident can be logged and sent back to Tesla. Engineers can then refine the algorithm and push updates to all other robots, preventing the same issue from happening elsewhere. This real-world learning capability means the longer Optimus operates, the safer and smarter it becomes. In short, to ensure that Optimus can work safely in kitchens, Tesla has implemented a robust safety architecture that includes full-body collision sensors, movement constraints when handling dangerous tools, kitchen-specific computer vision, real-time reflex AI, and continuous learning from user data. These are not just add-ons. They are essential requirements for any humanoid robot aiming to coexist with humans, especially in high-risk environments like the kitchen. We appreciate your contributions and hope you will have the most relaxing feelings after watching this video. If you did, please hit the like button and join the Techno Creator family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching, and we'll see you soon. Until then, stay safe and have fun.